Okay, today I created the SIMATIC AX project for our demo and added the first hardware configuration. During this process, I found a few interesting things that may be slightly disappointing, but it is what it is. Let's go straight to the project. First thing I did today is I asked my engineering manager AI agent Alex to create a Git repository in GitHub and publish all the information for this project there, so everybody who is interested can go there and check the progress and download the information. The repository is done. Let's have a look what's in there. Documents, notes. Okay, there's a process diagram here. Okay, looks all right. Okay, the next step will be to create the hardware configuration of this project. And when I build project with Siemens hardware, I prefer to use very convenient tool from Siemens named TIA Selection Tool, which is available online and offline. Okay, I have created the project already, just a blank project, named it AXtankDemoProject. Very simple, you just go to TIA Selection Tool page and then you click Create Project and enter the name. And now you are in the page of TIA Selection Tool. So let's create a new group, name it, for example, AXtankDemoProject. Okay. Add a new device, controllers. With the generation 2, it's possible even to use AI to build configuration, but I will build it manually. So the first thing you want to do is to add the CPU. So let's say this module, DC power, DC inputs, and relay outputs. And the module is in there. Actually, we could finish the hardware configuration just with this module, because this new generation 2 CPU is quite capable. It has 14 digital inputs and 10 digital outputs by itself on board. And also 2 extension boards can be inserted into the CPU itself. That can give us a list of additional inputs for analog signals or outputs for analog signals, and some technological modules like encoders, for example. But for the sake of this demo, I want to have some additional modules. So I would add additional analog I/O modules in here, but I will use digital inputs of the CPU itself. Digital inputs and digital outputs of the CPU itself. It's more than enough for us with enough spare still existing. So let's double check our project and go to our repository, GitHub repository, and check actually what's IO we already designed. And here we have a count of the modules. So we have of the inputs, outputs, we have 2 analog inputs, 5 digital inputs, 1 analog output, and 5 digital outputs. So digital signals we have more than enough on the CPU. Let's add analog inputs and analog outputs. So we will go back to our TIA Selection Tool, go to analog modules, analog input module, and take this one, 8 analog inputs, and then go to analog modules, analog output modules, and take this one, 8 analog outputs. As I said, it's much more than we need, but I just wanna use these to actually show more complex hardware configuration in SIMATIC AX to have CPU and IO modules in the hardware configuration. And maybe later we're gonna extend functionality of the project with these modules without needing to add more inputs or outputs. To order list, some errors, but looks like it's all shown correctly anyway. So that's it. We have a hardware configuration with the CPU, analog input, and analog output. Even suggests for the DIN rail, but it's just suggestion. The quantity is 0. So now we can actually export this configuration as a CSV file, for example, for my AI agent. It will be probably the best format, CSV. We will save it in the project folder. Config. Save. Now if you open the folder and CSV file, we're gonna have a list with all the modules we need, with the article numbers and number of modules. Okay, now let's create the project in SIMATIC AX. So I open the software itself, which is generally the VS Code fork. We have to remember that actually SIMATIC AX, at least for now, doesn't like the folders with names contain spaces. Probably later it will be fixed, but this is the reality right now. So I created not in a folder where I collect all the information and progress notes, but in just a root folder with my local projects. So I have a folder AXDemo, and I will do it here. Now I have got open the terminal. Another limitation that SIMATIC AX has currently is limitations of the project names. It does not accept capital letters. It does not accept spaces as well. So let's create a project. We're gonna use command apax create. Then the type of the project is HWC app, because this is a hardware including project. It's not just a code project for creating function blocks for TIA portal. That's a standalone project including hardware configuration. So let's call the project AXtankDemoProject. AX downloading all the dependence packages and creating Git repository, and now the project is created. We can see that the project is in here as well, in the tree, and all the projects, all the subfolders of the project structure of the project is created. To continue working in this project, we have to open it as a root directory, the project itself. So we open folder with the project and open terminal again. The first command is apax install. Okay, now let's see what hardware is supported by the project. I never tried to build the project based on the 1200 series generation 2 PLC. The support just appeared recently, so I'm trying here online. So let's see what the software, what the hardware is supported. Let's see apax 3. Okay, S7 1500. So looks like 1200 series is not added to the project by default. Let's check then what packages actually available in installation. Let's try to do search. So do apax search. Let's say S7. Okay. Oh, the first one in the list is package for S7 1200 G2. Great. So this package is supported. Apax add and just type the name of the package. Add AX/HW S7 G2. It's going to install the current version of the package. Okay, this one is done. Okay, now let's check what hardware is available in the package. Let's do apax hardware configuration, get supported devices. Okay. Oh, this one is, wait, this one is 1500 series controllers, signal modules. Okay. Interesting discovery. So it looks like we are currently limited for this project. So the only controller supported from 1200 series is DC 1212. So only one controller is supported and only 3 external modules are supported. Digital input 16 points, digital output 16 points, not relay 1, 24 volts DC 1, and analog input, analog output module. So only 3 modules. So yeah, this kind of tells us that 1200 series was added just recently, just I think a week or two ago, and I guess the team, Siemens team, is working on adding libraries of modules in there, but currently it just supports very small amount of numbers of devices, so just one controller and 3 devices. You can see that for 1500 series, quite a big list is supported. A lot of CPUs and a lot of signal modules. So generally, this discovery is not stopping us from continuing this project because we can still use 1212 CPU. It's okay for this simple project. So unfortunately, the configuration we just created in the TIA Selection Tool is not going to be implemented in the current configuration. Now we unfortunately will have to limit our hardware configuration by this list. But I'm sure Siemens will add all the existing modules soon. I hope so. Okay, so generally based on this discovery, now I can say for sure to someone who want to start designing the real customer projects with SIMATIC AX, probably the only right way to use it right now is using it in combination with TIA portal. If you open the page of the SIMATIC AX, we can see there's two ways of using it. IT like PLC engineering, which is standalone project in SIMATIC AX with hardware configuration and direct loading to PLC, and IT-oriented PLC engineering with TIA portal, where actually SIMATIC AX designs the function blocks and then load them, load the software into PLC, and TIA portal actually responsible for hardware configuration. Really, I don't like this situation right now. I don't think this is practical. If we have to handle one PLC project with two pieces of software, then it doesn't make sense for me, really. That's my point. I just rather use TIA portal, that's it. But I hope it is gonna change soon. I hope they're gonna convert most of the modules into the SIMATIC AX library, so we can add or everything into the hardware configuration in SIMATIC AX. But for now, it is what it is, and our target now is to learn how to use it, learn how to implement a real project with it, and hopefully soon it's going to be practically useful. Okay, just to make our project and project repository consistent with the current design decisions, I quickly rebuilt the TIA Selection Tool project to use only modules that are available in the SIMATIC AX right now. So I use 1212C CPU and analog input, analog output combined module. So now let's add the devices and hardware configuration in the project. Have to create a folder for templates, for hardware module templates. All this possible to do in the command line, but I am not the command line person, so I rather use SIMATIC AX user interface. So I just go here and say templates. Now I generate hardware template for the CPU. Here's the command. I just copy paste it. So here I say the order number, version number, and then where to create this YAML file for the template and the name of the template. And we can see the YAML file of the template is created. The next one is the analog input output module. Again, I have an order number here, version, template name and path, and yeah, the template name itself. Okay, generated, and then template is here. The file device PLC1, it's actually the device, the file which is supposed to list all the devices in this rack. So currently this file contains just a template of the configuration. Now we have to replace it with our own configuration. I'm going to just copy paste my prepared configuration on site to not waste your time on printing, typing this stuff. As you can see, we put the modules in here. Name of the device, modules for CPU and for input-output analog module. The question is, how did we actually compile these? But generally, that's quite simple. The modules have a template name with apply keyword, and then in the under the template name we have arguments. Arguments are actually set in the template as a placeholders. For example, for the CPU, if you open CPU, and here at the beginning of the file we see placeholders, and here the arguments actually listed that we can use: the name, and then IP address, and then provenance device. That's from where we actually take these three ones. And then if you open the analog input output module, again, placeholders, name, input address, output address, and we use them here. Worth noticing that in the analog input output module, we do have these placeholders for input address and output address, so we can set these addresses directly. For the CPU, although it does have digital inputs and digital outputs, we don't have these placeholders, so we cannot set input and output addresses directly here in the configuration. I will check it when compile the project, and then I think these addresses for the CPU should be generated by the compiler, and we're gonna see it later. Okay, the next step is to compile the hardware configuration. Compiler messages. Okay, failed to load security configuration files. So we actually have to first run the security configuration of the project. Okay, let's configure the security configuration. So we run apax hardware configuration setup secure communication input. Module name here is PLC1. Master password, that's what we have to set. Demo 1, 2, 3, for example, for 5. Let's try. Okay, setup secure communication was successful. So should be all right now. Let's try previous command then. The compiler tells me that I have to create a certificate. security certificate. After investigating a little bit of how to do it, I found in that main project file, Apax YAML file, this line create certificate. This create certificate command is actually what we have to use, insert necessary parameters in here. So I'm just using my prepared command already. Do not type it here. So this one is actually that command. Now these parameters, IP address, OPC TCP address and port, DNS, you can get again from the same file. From the same file variables, IP address variable, here's that we take it. OPC port, here's the way we take it. DNS, here's where we take it. So it's not invented by myself or someone. We just take it from the generated YAML file. Okay, I did open the Windows PowerShell. I think it's actually possible to do in terminal in AX. I have to just configure it. I'm not an IT guy, so it's kind of, I have to investigate how to do it. But let's, here. Okay, all done. See the certificate folder. Okay, this one should be done. Now we will try to compile it again. Okay, looks like I do have created certificates and we can see them in the certificate folder, but I have to import them, and this one is command to do that. Okay, import certificate is successful. Let's try to run the compiler again. Okay, the next thing is missing is the user password. So we have user1 configured as a user. Let's configure the password for it. Demo user. Okay, the user password compiled. Now let's run the compiler again. Okay, the compile succeeded. It has couple warnings that user1 has function right for OPC, but not OPC. No web server, no OPC server. We are not interested about that at this stage. So generally, yeah, the hardware configuration is compiled. Okay, now that we have compiler successfully finished compiling hardware configuration, we do see this folder in hardware configuration folder, subfolder hwc.gen, and here we do see generated hardware configuration files. And this one, PLC IO addresses, is actually what we were looking for when we were checking the addresses for. CPU modules, and here we could see that you see PLC1 has 8 digital inputs and 6 digital outputs, and here the hardware identifier, which often used when we build project with Siemens modules, inputs addresses, and I guess here we can change them if you want to. And then description of these input-output channels. Same for outputs. Here the module analog input out module configured as well. Here is analog inputs and analog outputs. The address is here. Okay, at this point I will stop this part. The project has a public GitHub repository, TIA Selection Tool hardware baseline, and SIMATIC AX hardware configuration that actually compiles. This step also showed a few very practical lessons. The hardware configuration in the real Siemens catalog currently supported by AX hardware compiler is not full. And so unfortunately, generally this type of workflow is not fully customer project ready yet. But I think Siemens will fix it soon. The 1500 series is already much more usable, and most of the necessary modules already there. 1200 series is just started, so hopefully in a couple months it will be ready for full usage as well. So it's still worth to learn it, study how to use it, and get a practical experience with that, because I'm sure in short time it's going to be very main direction of industrial software development. All the work we done today in the last session is saved in GitHub repository, so all the files and guides how to do it are saved in there. I want to be clear with one thing. I know that this process of working with command line, fault finding the issues in the command line, all these certificates, compiler issues, and things like that, it's all difficult for us coming from electrical controls background. We used to work with user interfaces, not with command line. But important to understand, SIMATIC AX is a new generation tool which built as very friendly to AI assisted engineering. So generally, I just showed this process today doing myself, just to show that's all how all this works, to show each step. But in fact, in real development life, I'm not going to do it myself. I just tell the target to my AI agent, and it will generate all these routine stuff. Generate the project, create the project files, create the hardware configuration files, and compile everything and fix all the errors and compile until it's successful on the background automatically. And because it's all work with text files, that's the advantage of this tool, because it's all text files. They all can be worked with AI in the very efficient way. They all can be version control with Git, and this way each step can be version control and saved. And you don't need to remember anything. You don't need to remember command lines and all these protocols. Everything is done on the background. What you need to know is you need to know what the final target result you need to have. You need to know how to check hardware configuration, in what file it is saved, and how does it look like, what modules in there, things like that. So you have to be able to validate the result, but you don't need to memorize all this complex stuff. It's all easy. Trust me, I am not IT at all and never was. In the next article, we're going to switch from the hardware to the software. Functional structure of the project and function block interfaces. Make it simple, automate it.